Hi everyone, thank you so much for joining my session. And this session will be about Terraform practices. So Terraform is a great tool, right? It is used widely across the world. And this talk will cover not only specific bits and pieces regarding Terraform usage and practices, but also hopefully will make you think about your unique use cases and scenarios and help you see the big picture and utilize Terraform in a broader context rather than just an infrastructure as code tool. And that way you will be able to scale up your infrastructure and your teams who will use Terraform as well. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. Recently, I have joined the AWS Community Builders Program, which is awesome. I help co-organize conferences in Israel, where I live, DevOps Days Tel Aviv and StatsCraft Monitoring Conference. I'm a mentor in courses and communities. I am a DevOps culture fan. I think this is what helps companies achieve great things. And I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. Okay, so let's start and talk about Terraform implementations. And we need to understand that sometimes they can be good, bad, and also sometimes ugly. One disclaimer, I'm mostly going to show examples from AWS, but of course, Terraform works with all cloud providers. And I'm talking about open source Terraform, the open source edition of Terraform, and not cloud or enterprise, which I assume that the implementations are a bit different. Okay, so let's start with quick wins. And when I say quick wins, I mean low effort, high value things that will help you scale better and more efficiently, prevent refactoring and extra work later on, and basically things that you can achieve in a matter of a very short time. So first of all, versions lock, same as for requirements.txt for Python and package lock JSON, we can lock versions for Terraform as well. So we can lock modules, providers, and Terraform versions. And the version basically means what features are included in that version and the expected syntax. And this is how you do it. So the thing about locking provider versions is that we need to understand that sometimes there are issues. And as this meme suggests, we need to lock versions because at least that way we deal with the devil that you know. So the good thing about versions lock is that if we lock everything that we can, modules, providers, and Terraform versions, that it will be the best way to go. The bad thing is to lock in a way that will still allow breaking changes to occur, because if we lock to a minor version and not a major version, then it could introduce issues. And the ugly thing is to have no versions lock whatsoever. Trust me, you will have syntax issues, a lot of things. Don't go there. And the thing about having consistent versions and no conflicts or breaking changes, it's good because it will help your teams in the long run. The second thing that I want to show here is tagging resources. So I believe it is a must implement practice because it will allow you to filter your cloud provider expenses and sort them by tags to distinguish between resources. It will allow cost control in other tools like Datadog, for example, that it is done through tags. It will allow to gain visibility on ownership and overall projects by tagging according to a logical breakdown. And trust me, if you tag resources, your FinOps team will be happy. And if you don't have a FinOps team, congratulations. It means that you are the FinOps team and you need to take care of cost management as well. So these are examples for tags that we use in Wix. And on the right, you can see that the AWS provider has default tags, in which it means that you can set tags that will propagate throughout any resource that gets created in this under this provider. And then you just forget about it. You set it only once, and then all resources that are created in AWS will get these tags. So the managed by Terraform is a very classic example for using the default tags. So the good thing is to tag everything that you can, use default tags as I just mentioned, and a very good thing is to do PR enforcements, in which if someone introduces a code that doesn't have resources that doesn't have tags, then the PR will merge. It's failing. The PR merge will fail, and I will cover the practices enforcement a bit later on. The bad thing is to tag inconsistently because, as we know, consistency is key. And the ugly thing is to have no tagging whatsoever. Trust me, cost management will be very hard, and also projects tracking will be hard. So try to avoid that. The last thing on the quick wins section is remote state. So by default, Terraform works with local state, and remote state helps scale your teams because everything is remote and you have one source of truth. So this is an example of how to do the remote state in S3 bucket. So the good thing is to have your state remote and secured, have the state backed up so you can enable S3 versioning, for example, and to have Terraform state lock. You can do it with DynamoDB as well, which means that if you run Terraform apply, the state gets locked and nobody else can run Terraform apply on this state file, and then no conflicts will happen. And the bad and the ugly is pretty much the opposite. So having local state or having the state remote, but not having the state secured or backed up, and to have no state lock when you run Terraform apply. So these were quick wins, things that you can achieve in a matter of minutes or a very short time. So now I want to cover second nature. And when I say second nature, I mean day-to-day awareness that will help you reduce refactoring code in the long run, prevent time waste, and align to best practices as much as possible. So the first thing is using community models versus creating them yourself, because there's a saying, right? Do not reinvent the wheel. A lot of well-known cloud providers' features are already covered by models, so do your research. Check for available models before implementing yours. And the thing about using community models, it's good because they are proved over time, they are supported by the community, and you eliminate the need to support it and keep it up to date because they do it for you. And also, community models usually use enforced linters, formatters, and logical checks to allow new users to get easily involved, contribute to the model, and use it while preserving high quality of code, which is very important, and thus making the model more robust in the process. So the good thing is to use verified community models where possible. Of course, if it doesn't fit your use case, don't do it. And when I say verified, I mean that until recently, you had verified labels on Terraform registry, the models in the Terraform registry, but HashiCorp removed these labels. So just check the amount of downloads for the models. And if a lot of people downloaded the model, probably it means that it is safe to use. The bad thing is to have a custom model, but still maintain it as a community model. So if there is a community model exist, but you create one of your own, but you still maintain it properly, then it's still quite okay. And another bad thing is to use community model without a version lock, which, as I stated before, it could have issues with that. The ugly thing is to have a custom model and don't maintain it, aka don't have any checks or consistency, don't have code practices applied. So this could get nasty and out of control. So try to avoid that. And another thing, the ugly thing is to use unverified community models because it could potentially introduce malicious configuration to your code base, and we don't want that. So if you do have to create your own models, make sure you make them stateless and clean, and they are generic as much as possible, and you do not repeat yourself if you don't have to, and the code is kept simple as much as possible. And there are enforcement to maintain quality, as I mentioned before, like that the community models have enforcement to make sure that the code is kept in a high quality. So if same as for community models, you should have the same principles applied to your internal models as well. And I will cover practices enforcement in a bit. The next section is variables versus locals. So unlike variable values, local values can use dynamic expressions and resource arguments, and locals also don't change values during or between Terraform runs, such as plan, apply, or destroy. And you can use locals to give a name to the result of any Terraform expression and reuse that name throughout your configuration. So, for example, I can have variables of project and environment, and then I have a local that has a required tags, like a set of tags that are required, and then local does the merge between the required and the project and environment. So this one example for that. So how to use them? For variables on the module side, their purpose is basically to have settings for the module configuration, but make sure you set up default or validation to make sure that if someone uses this module, they don't pass values, then the module will break, right? So if you set up default invalidation, you prevent this from happening. On module side, for locals, consider it as a constant to be honored or relied on. So for example, if I have a module to create an S3 bucket, I can set up naming convention for all buckets that gets created through this module. And that way, everyone that uses this module will be bound to this naming convention, which is good because we want to have consistency. We want to have a naming convention for all our buckets to make sure we are aligned. And just a small note about this specific example is that about naming convention, you should think about the limitation of your cloud. So if the cloud has a characters limit, for example, you need to take that into consideration. So I covered the module side, and on the live side, and when I say live, I mean where we call the module. So a module is like a class, right, in code, and live is like the instantiation of a class. So on the live side, for variables, if you use them once, so just set a default. But if you use them per region, etc., then use tfvars file. And for locals, you should really avoid using locals as much as possible because we want to keep the live side as simple as possible and leave the logic to the model side. So try to avoid that, and also try to leverage data sources and pass their outputs to the model, because that way we use dynamic configuration that we fetch. And dynamic is great because it means that we will have the up-to-date configuration to our disposal. So in regard to variables and locals, you should use tfvars where necessary. You should utilize environment variables because that way you have like a built-in variables and you don't need to create new variables to compensate on that. You should use locals to dehard code one-time names, decrease code repeatability, and have a general notion of keep things generic as much as possible. The bad thing is that Terraform allows you to set up multiple local blocks. So if you don't really have to use them, just use one or as little blocks as possible, because that way you make the code more maintainable. It's much more readable that way. People maybe will spread out the blocks throughout files, and it's very hard to maintain it that way. So if you don't have to create a lot of multiple blocks of locals, don't do it. Decentralized vars, so just keep the variables in one file and it will be easier to maintain. And ignoring environment variables is also not good because, again, you need to compensate with creating more variables that you need to maintain later on. The other thing is to have hard-coded variables values where not necessary, because that's exactly it. Variables, they need to vary. So if you don't have to hard-code, don't do that. The next section that I want to cover here is file structure. So as we should know, Terraform executes all files with the TF suffix. So, but for better logical arrangement and easy management, we should have a file structure with naming convention. So we can take an example from the community standard. And on community models, we have this file structure, the main TF, which includes the main logic of the model, and then variables for the variables, data for all the data sources, and versions for all versions I mentioned at the beginning, provider versions and Terraform versions. So this is the structure, and we really need to think about a naming convention, and it's best to have naming convention which reflects the actual purpose of each file. And that way you will get a decent logical arrangement for faster access, better readability, and cleanliness of the code. So for example, if we have a main TF which is complex, we should break it down in two ways. So first of all, let's say, for example, that we have a module for creating a VM, right? So the main logic of creating the VM should be in main TF, but other things, other peripheral things like creating load balancer or security groups should be in different files. So this is one example for break it down. Another thing is for a complex module. So if you have a complex module that you created, consider breaking it down to submodules. And that way, first of all, variables will be bound to the module and the submodules, and then you wouldn't have one gigantic variable file to to maintain. And also, if you have submodules, you can reuse them separately and independently, and it's good because you don't have to call the entire module. You can also only call the a submodule. And we can see examples for that also from the community modules side. The EKS community module has a submodule of the creation of the node pools, and the VPC module has a submodule of VPC endpoint. So that's regarding that. Okay, we reached a section where I really like to talk about, in which I talk about applying classic code best practices on Terraform. So before you jump the gun, yes, Terraform is not a pure programming language, but similar rules of writing code apply to Terraform as well. Terraform progressed over the years in a way that adopts code best practices. And for example, you might remember that before Terraform 0.13, you can't even use for each for modules. And with the release of this version, HashiCorp finally introduced the ability to loop over modules with a single module call. So that way, we should really apply classic code best practices on Terraform as well, which means we should keep the Terraform code in a source code knowledge management, GitHub, GitLab, Bitbucket. We should keep the code as simple as possible. Do not repeat yourself if you don't have to. Even functional programming principles can be applied on Terraform, and the code should be idempotent. And in regards to human and clean, I want to quote something from a great article that I will have a reference to it in the last slide by Thyssen Ur. He wrote, and I totally agree, that the computer that processes your code doesn't care if the variables names are ambiguous or inaccurate. If used correctly, it will get executed, right? But since human beings are the ones to maintain this code, we need to make sure it is readable. So things like refactoring, clean code, naming conventions, etc., are invented so that we humans can read the code better for the sake of us humans and not for the computers. So that's why it really is crucial to apply classic code best practices on Terraform as well for better management of the code in the long run. Okay, so we covered quick wins, right? Things that we can achieve in a very short time that will help us leverage Terraform in a very good way. We covered second nature, things that we should think about in our day-to-day when we use Terraform. Let's now talk about the long haul. And when I say the long haul, I mean things that we need to plan ahead when we work with Terraform. So let's think about it this way. We work in a company, right? We need to collaborate with people. We need to add resources, scale, right? Scale teams, scale infrastructure. So for different teams working on the same infrastructure, or doing audits on that infrastructure, considering the long haul practices will allow them to have the needed visibility on that infrastructure. And it will also allow them to isolate environments and their changes or effects, right? Dev, staging, production, and scale Terraform usage by teams and scale the infrastructure itself more easily and efficiently. So I will cover practices that will help with all of that. But beforehand, I want to ask you one question. How do you envision the infrastructure and the company needs? So I believe that we really need to think things through and do what's best for the company's needs and infrastructure use cases. And I will give you example for that through a story. So I work in a DevOps team for the data engineering group, okay? And I manage the infrastructure for their data tools like Presto, which is a tool to query data. So in one of my daily syncs with my team, we raised an option to move Presto to Kubernetes because until now, Presto is installed and runs on a fleet of machines that scale over an auto-scaling group. And there was someone raised the option to move it to Kubernetes. And then all my team members were like, yeah, let's move to Kubernetes. Yeah, let's do it now. They were really excited about that. And between me and myself, I was excited too, because think about it. Kubernetes is adopted in a lot of companies, right? And it's very complex. So, I mean, I have experience with Kubernetes, but there isn't enough experience when it comes to Kubernetes. It's very complex. So I want to work with Kubernetes more, right? Because it will help me in my career. It will help me if I leave Wix where I work and will go to other companies. Probably they will appreciate this experience, and it will help me in the day-to-day, right? So I have everything this in mind, but I didn't say that. I stopped and I said, wait, we need to think about the application needs. Maybe Presto doesn't know to work with Kubernetes. Maybe there aren't production use cases that we can look for references. Maybe the creators of Presto say that it's not suitable for Kubernetes in the current state of the application, right? So we need to, buzzwords is nice, and Kubernetes, we all want to work with it, but we need to think about the application needs, the infrastructure needs, and the company's needs. And that's why I introduced this question to you, because it's a very important question to ask yourself, because this will shape how you address things later on, not only for Terraform, but in general. So because we planned things ahead and thought things through, we hence decided to use Terraform and structure the code base in a way that makes sense to us, and I believe that will make sense to you as well. If infrastructure and team scaling is something that you see when you envision the infrastructure and company's needs. So let's cover the structure of Terraform code base that we have in Wix that I believe will benefit with you as well. So this is the structure. We have team, project, cloud provider, and region. And then this is the implementation. So we have live and modules, right? Modules themselves, live, where we call the modules, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. And why did we choose this structure? Two reasons. First of all, Terraform is a platform, okay? So enabling Terraform as a platform is good because it allows us to onboard all teams to the same repository. We all use the same repository for Terraform. New teams can onboard and have to create their own root folder and basically manage their code. They have a complete autonomy of their code because we leverage code owners in GitHub, and that way for each team, we define the groups or the users in GitHub that can approve and review and approve the PRs. So they have complete autonomy for that. And because they are onboarding an existing repository, they get out-of-the-box models that everyone else is using, which is awesome. And then because they have already things that they can use. And also we have practices enforcement. I know I'm creating a build-up for that, but I'll get to it very soon. So the practices enforcement is done on the repository level. So it is done on everyone's code to make sure that code is in a high quality state and to enforce any other practices that we have in mind, like make sure that everyone adds tags to the resources. So all of these reasons is good to have for Terraform as a platform, and that's why this is one reason why we did it. The second reason why we did it is to have small state files set up. So I hope that you know Terraform creates a dependency tree for all of these resources, and sometimes Terraform doesn't create the best dependencies. So in order to help Terraform do its job correctly, we need to make sure the small state files are, the state files are small. That way we eliminate big blast radius and minimize invalid dependencies. Because when I worked before with huge state files, I remember a time where I just added a tag, and then on the Terraform plan output, I saw it's going to destroy a resource. I'm like, what? I just added the tag. So that's the thing. Huge state files is not good because it will encourage Terraform to create invalid dependencies, and it's not good in the long run because it's very hard to maintain it that way. So in this structure, we have small states because the state is kept in US East 1 level, which means that the state file is only for BI team Airflow resources in AWS US East 1, which is very small and contained state file. And that way, it's very easy to maintain it that way, and we eliminate big blast radius and minimize invalid dependencies. Okay, so I want to cover now some stuff about workspaces again, open source ones because it is implemented differently in Terraform Cloud. So workspaces isolate their state. So if you run Terraform plan, Terraform will not see any existing state for any other workspace. And it's good to use workspaces in a scenario where you have the same Terraform config for different customers. So let's take GCP as an example. Each customer is a different GCP project. So and they share the same Terraform config because they are basically the same. So if we have same Terraform config in different customers, then each customer can be a different workspace. Coupled with that, if all customers, for example, needs to use the same service, like financial service or login service in different regions, then these can be defined in workspaces as well. Some notes about workspaces, though, is that you should consider using a Terraform wrapper when you work with workspaces, because how do you work with workspaces? CLI, Terraform workspace select X. If I forgot to do this select, production incident. Okay, so try to avoid that and create some sort of a Terraform wrapper. It can be like a mini system written by Python that manages the Terraform workspaces switch for us, and that way we avoid any human errors. We also need to understand that we have less visibility with workspaces, because even if we use Terraform workspace conditional, built-in conditional, it doesn't mean that all workspaces are in use, because I can do Terraform workspace list to see a list of workspaces there, but it doesn't mean that they are actually in use and being production. Maybe someone created it for tests and forgot to delete them. So we have less visibility, and we need to understand that, especially if we decide to go down this path of choosing to work with workspaces. Some notes about workspaces is that from the documentation, it says use workspaces to manage multiple non-overlapping groups of resources with the same configuration, which basically suggests what I just showed for multiple environments, regions, etc. But the documentation also says that for the same multiple deployments of the same infrastructure serving different development stages, the named workspaces are not a suitable isolation mechanism for that. So I never worked with infrastructure that served both dev and production. I don't know if they meant that, but if it raised the question for me, maybe it will raise a question for you as well. So just bear that in mind. At least we can agree on one classic useful workspace, like a side branch. You create a workspace like a side branch, test out any complex changes that you might need to do. Once all checked out, then you apply them on the default workspace, which is production. So the good thing is that when you plan ahead and really think things through, for structuring your Terraform codebase, it will allow small state setup and Terraform as a platform. And the bad thing is that maybe organizational changes might require you to restructure code, and we don't want that. We want to have a control of our code base and using workspaces for the wrong reasons. And the ugly thing is really, if you structure your Terraform code base in a way that will allow huge state files, it will create invalid dependencies, big blast radius, and it's very hard to maintain it that way. The next section is Terraform Execution. So aim to have remote execution because it's good for scaling teams, right? Everyone can use it, and you have a ability to handle state lock, as I mentioned before, because if you use, for example, Atlantis, which is an open source tool for Terraform pull request automation, it handles the locks for you. So aim for remote execution always. You can also apply Terraform with a plain file, and that way you know exactly what you're applying, and you should set up Terraform timeout that makes sense to you. The bad thing is to execute locally, because that way you need to have local credentials, local configurations, and you don't have audit. And the ugly thing is to execute locally and click and do Ctrl-C when you run Terraform apply. I did it when I just started out with Terraform because I didn't want to wait for the timeout, and then it messed up my state. I don't know if they fixed it by now or not, but I don't want to find out. So that's about that. Let's go to practices enforcement, which I had to build up all this time. So practice enforcement basically means that you can have any guidelines that you want to enforce. Basically, if you want to alert FinOps to if the infra cost is more than $10,000, or you want to make sure resources are tagged, or you want to make sure the quality, the code is in a high quality state, like the code is reusable and clean and readable, right? All of these things can be covered in practices enforcement, and I will show an example now. So in AWS autoscaling module, the community module, these checks are there to check if the contributor formatted the code, Terraform FMT, if they added documentation, and if they added a working code, which is TF-Lint, but also TF-Lint is good because it checks best practices, like if you put version for modules, for example. So these are checks that you can set up, or any checks that you see fit, and make sure that everyone that introduces code changes follow these practices. So the good thing is to have pre-merge linters, formatters, and logical checks. You can do it with GitHub Actions. You can do it with CI pipeline checks. Sorry. You can have Slack bot drift reporter to report on drifts, or you can do what we do in Wix, in which we leverage Atlantis that I mentioned. That way, when I do Atlantis apply, aka Terraform apply, it applies the code and merge it to main. And that way, main equals the actual environment. The bad and the ugly thing is to have, is actually if you don't have practice enforcement, because then you might face security issues and maybe even non-compliant configuration introduced to your environment. And on the right, I have some tools that will help, open source tools that will help you in your journey of implementing practices enforcement. So I want to ask this question again. How do you envision the infrastructure a company needs? I hope that I showed you this question is very, very important. And if you ask this will shape everything that you do in the cloud. So these are the key takeaways that I want you to take out of this presentation. If it's not big enough, tell me and I will enlarge it next time. So you should take into consideration use cases, pain points, TF constraints, where do you see the infrastructure management and the company's needs in the long term, and plan accordingly. Because if we wouldn't plan accordingly and plan ahead, we wouldn't be able to set up Terraform as a platform like we did in Wix. So Terraform as a platform, small state files for the win, and practice enforcement will really help you enable infrastructure and team scaling. And even if you're a startup, think about scale. How should you address and prepare for changes to come? And then you'll be able to utilize Terraform in the best way possible. And I want to finish with another quote from the Thyssen-Uhr article. You should really read it. It's very good. He said that programs evolve and code changes, right? And it's really uncommon that you write Terraform code and it stays the same, because this is not how projects work. If it was the case, then we wouldn't be even talking about Terraform practices here, right? All of us would just use it the same way, write the code, and continue with our lives. But we will always have projects because businesses want to improve, and changing from the current state to the next desired state is a project. So you should really think about how you structure the Terraform codebase and treat Terraform generally. That way you will allow projects to evolve and get introduced, helping your company improve and contribute to the company's success, and enable infrastructure scaling and your team scaling as well. These are references of things that I covered throughout the talk: labeling, tags, workspaces, documentation, the Thyssen-Uhr article, and Superlinter is a bundle of checks that you can add to your practice enforcement. So thank you so much. I know that I spoke quickly at times because I have a time cap, but if you have any questions, you can reach out through mail, Twitter, or LinkedIn, and I will be more than happy to help. Thank you so much.